Hi all. So today, myself, Levin Vincent, here to represent the particular project which have been worked upon for the part of the challenge, which is conducted by IDC Indian Data Club, along with Codebases, sponsored by Databricks. So my project is typically PaySim financial fraud detection and risk analytics. Is an like ML based uh, an ML project which have tried basically to include what all challenges which we done for last 14 days as part of IDC challenge 2. So I just covered all the components. So I'm more happy to explain you step by step. I hope I'll just covered with what is the problem and what is that architecture which we are using, what is the ML pipeline which we have built, and what is the what all models we did. How do you, how do as a data scientist, how do you think about comparing the models, and how do you do the effective way of doing experimenting and doing pipeline setup, everything in Databricks, ending up ending up with a beautiful dashboard where any business stakeholders they can view and understand it. I hope this will be along with followed with the documentation which I'll be covering up, ending up with this particular 10 minutes video. So here let's go up with the first phase of explaining what is the problem statement. So here let me just start with the idea which coming from that uh, uh, business background. I taken this example. I started with I'm just showing the dashboard first to get your idea interest on this particular problem. So my problem is an mobile based fraud transaction thing. So that is a normal data set which I gathered from Kaggle, and that from the data set I've done my EDA and done my modeling everything, and from that I've depicted what all things which I can bring meaningful as part of this project. So this is the end result of this particular project. So that's why I thought of giving an output first and thought of deriving what I will can go ahead. So to start with, right? So we have that link of this particular Kaggle site. So this is the financial data set of fraud detection data set. So this is basically an PaySim-based company which has been taken one of the sampling in African countries, and in this particular Kaggle has around 1/4 of the total data set, and this has been like more in the while into the system. So I've taken the same. It's a low file, like 6.3 transaction is what a million transaction is what is there in that particular file, and I've tried to bring out the best problem solving on this particular thing. So here in this problem, it really states that you have a transaction coming into system. You need to identify whether it is a fraud or it is a legitimate transaction. So and they are multiple ways transaction may happen. Either you're doing cash out, either you're doing a transfer, or any other ways the transaction may happen. So while doing it in mobile, right? So these sort of frauds can come up in. So from these records, we have tried to understand since the transaction, and we are able to classify whether it is legitimate or fraudulent transaction. So I've taken this particular um, Kaggle dataset as an example. So that's about the dataset part. And moving to my repo, so I think my repo is like which encompasses all things components. So I'm just more interested. I've added those data sets over here, and I said it's like 6.3 million transactions what over here, and these are the columns which are present in this particular data sets. Like what are the types? I said right payment. What type of, is it a transfer cash at, or is it a single payment? It's an amount. So all those columns. It's like hardly around 11 columns, 6.3 million records. So that is an overview of this particular data sets all about. Yeah, and I think let me just uh, jump into the what is that architecture behind which are implementing it. So let me just maximize the screen so that you can just visible, right? So yeah, I hope it's visible. So if you see that this architecture is a combination of advanced level 2 is a combination of you have the data pipeline which really builds based on the Medallion architecture, followed with that ML pipeline also. So that's what we did. So here I just used Kaggle as a base. From that base, I'm just doing the data injection directly into the bronze layer. For creating the bronze layer, since we're working on those serverless data bricks, so we used volume schema as a base, and from that we loaded those things files into that bronze layer, and we did a little bit of silver layering, and follow with the gold layer. I will explain more into it because this is pretty much similar to any metal architecture which we did. And advanced level, when you see that model training is done. So as we know that our business problem is nothing but you have a transaction, we need to classify it as like either it is an fraud or legitimate, and we use it's a normal binary classification, right, as an ML point of view. So for that particular one, i'm I thought, like, if you think about data scientist point of view, we will try to have three basic things. One is like logistic, random forest, and the gradient boosted trees. I use the three of this model and try to find the best AUC. Okay, so it's area under ROC curve, and I try to take the best fit of this particular model for this particular problem, and then I did the future engineering. Then I later on ending up with registering the model, everything. So all thought of thing. Then from that particular uh, insights, I created that goal prediction table. So this is the entire flow of this particular use case I built as part of it. So I think I initially stepped into this particular dashboard, so which really means that you you need to make that end user understandable, right? So what all the I'll get into more deeper when we go, but I thought since it's a part of my README in the GitHub, so I thought of this. So these are the key insights. What are total transaction volumes? What it's like whether it is fraud or legitimate. Which all pay transfers are like, let's say, cash out, transfer, payment. Which are of high risk, which are of low risk, and which all are the fraud and which are all legitimate. And other one is like how much of them risk are of risk payments have been done, and which all accounts are considered to be legitimate or legitimate or fraudulent account. So these sort of things. And I've added one more component to it is called data quality monitoring also. So we as an when you think about data engineering and ML sort of pipeline, both things, it's a perspective that you have your data should be of a particular quality when we define something. So I've added that component also so to monitor it, because we don't need the end users or business people to judge that without on the top of qualityless data. So I've added that component also into it. So this is a far readme page, how it looks and all my project is all about. So rest all, I thought since I was staying in that my GitHub, I will explain. So here if you see that what's the screenshot of my dashboards, it's my pipeline job. So I kept it YAML files as it. So I've never built Databricks bundles sort of things into it. I kept it pretty much simple. So bundles over it, and it's like guidelines which is shared by the IDC and Codebasics. These are scripts, right? So these scripts involve like I think like there are six notebooks page which I've loaded into it. Another one is like architecture of it. So I kept three documentations specifically. One is that uh, the PowerPoint presentation which I chosen to explain your, and second one is that why what is the data set, what all is columns, what what class, what is it like, is it simplifies to binary classification, and that particular point is what I'm just trying to explain, and why did I choose that model, and what all things I can explain on it. So I think these features I explained it into the README page. I kept it into a more broader view of this particular document, And third one is like for entire documentation of what all codings or a snippet of code, I would say, rather than, because I don't want that clumsy. So a snippet of code is kept. So that's all about this particular GitHub looks for this particular project. So let me jump into that each section of it of Databricks components. So okay, so I'll start with the explaining the dashboard, right? So you have the transaction type. So as I said that you have mobile transaction we do with maybe a debit or like cash out or payment or transfer or this thing, what also. So in that first tile, you can see that how many of them are like fraud transaction, one is legit transaction. So that sort of classification I've done. And out of all this, I think this data set is pretty much clean. You can see only that low risk is what it can depict, because there are nothing much. And I said right initially, my objectives of this particular thing is also how many accounts are a fraud and are there of which type. So I think that is also I'm just captured in the third tile, and fraud alerts, right? So if you see that as a business point, they are need to cut short, because you know that uh, this sort of precaution measures are used to stop such fraudulent transactions. So we know that there are cash out and transfers. These are two forms of transaction type where fraudulence are happening more often. So that's also it. And this is nothing but I other tile which explain more about out of how many transaction, how many of them are fraud or of which cash out type. So it's a drilling down of the previous dashboard I did. So I just drill down out of total, out of what is a fraud. That's it. Yeah, and this is nothing but data quality also I kept it. So let's say your business when we business people they see it, they need to make sure that this particular uh, judgment or decision they are making is on that quality data. Okay, so since I've already done, so let me just straight forward. Like so, if you see that there are two transaction type. One is payment type, and other one is like yep, cash out. Okay, so I think these two areas is what we could see a lot of things like. Okay, let's do one thing. Let's take at least first cash out way. Okay, let's say let me take the transfer one. Okay, transfer. So you can see that in how do we read that particular dashboard. And for the transaction type transfer, we have like fraud of 50 percentage, like 1.97 records, and others like 530 records listed of legitimate transaction. And here, these are the accounts which are of fraud based, which has the transaction type thing, and they have low risk about 530. This account this matches, and these are the records which are of fraud alerts has been done. So that's it. So I think if you add cash out also to it, right? So we'll just get the combination of it. If you need to try to exclude it, right? So I think most of them will be in pretty good shape, because these two areas is what in this particular data set which we felt it's more uh, meaningful for the decision makers of the business or the banking sector. So that's all about pretty much around this particular thing. So I think more interested is how do this logics really stand upon. So I think there's a snippet of code of each thing. So I think there are about 6 snippet of code for each tile which logic has been created. As in Power BI, we use Power Query sort of things. So here we use a snippet of code to bring that meaningful ways or else way how to identify those uh, alerts. Yeah, so I think that's it from the dashboard's point of view. Let me move to that pipeline basis. So as I said, that first three things. So if you see that there is data ingestion, nothing but uh, we are reading from that uh, in Kaggle directly into the particular landing page. So we're just configuring Kaggle credential and loading into that bronze layer. So I thought initially let's have that AWS bucket in there, but I think it's a duplication of work, so I just kept it simple. It's the same methodology they used, and kept it into landing page. Next, I used that silver layer, gold layer, and I kept all the components. Like let's say if I meant by component, like I did all the feature engineering, training of the model, and registering the model. All that components I kept it in the same similar components. Because the creating and everything data frame again another dashboard which really this is something data quality logs. Normally should come before of uh, gold layer or before about data pipelines, but I felt since this is out of scope, I kept it volunteer at the end because it didn't want to lose that shape of that existing agenda of that project. So this is all about that pipeline building, and I kept the notification everything. I didn't schedule it. I remote schedule. So this is it had run, but obviously there are a lot of false failure jobs also, which I kept it cleaned and tidy for this particular thing. Yeah, and I think one more thing I thought of showing you is that experiments. So if you just see that experiments, right? So if you check out this particular one, right? So these are the this is where I just registered the model. This is a space where which normally I registered the model. So model registering is done over here. So this is once you do that feature modeling everything, that ML component will save that model register everything into this particular catalog. So that space is what I proceeded over here. Yep. So I think let's move on to that single from data pipeline to ML pipeline. So here we know as simple, which I configured that Kaggle credentials and just loaded into that volume for this. And initial phase is nothing but you load everything into that CSV file and load into that particular delta frame and save into table. So this is nothing but the uh, st- data subset of this particular uh, problem statement, and this is a bronze layer. So okay, and this is nothing but silver layer, which I felt that more when it's bronze layer directly is you load the data without any touching it. But I felt that there should be some sort of documentation included. So I kept some documentation, everything line commenting properly so that should look like a protection code. So I kept that all this information, what all columns I've added into it, and I checked for a deduplication also into this segment also. So rather than here also I kept to ensure it. So just validated it uh, and just writing directly into that silver table. So that's it. So these are the things which I uh, try to do with just adding few columns into it. So I probably added like three columns into it. That's it. I'm not going much in detail. Let's move to gold layer. So gold layer, I just kept the aggregation of it. So okay. So this is some risk summary, right? So each all there are multiple tables involved in the gold layer. So let's say that my schema is fraud detection, and there are like multiple tables lying at fraud risk summary and like what all total transaction and fraud transaction, what is the average amount. So each and every snippet of code really makes different perspective of it. So that's how it mentioned over here. And yep. So let's me move on to the ML, which probably all will be interested in it. So yeah. So as like this is a binary classification, and we know that when I'm just training the model, I need to peculiar. There are uh, three models which we basically use: logistic, random, and gradient booster trees. There are some other models also, but let me just I stick on into three models, and in these three models we typically compared what is the AUC or it is the area of under ROC to check for which is the best one. And here if you see that I calculate AUC for all the three models, and here that we found that gradient boosted tree is the best fit, and I've assigned that particular value model value to the entire uh, training the model and registering everything. So this is why I mentioned that a selection of model is a choice. And now this everything registering the model, everything which I have done over the top of it. So these are some challenges which I went and just overcome. Like you are running the pipeline and just trying to delete it each and every time. So those things I've just included all here. Yep. So up to this I just covered. Later on I creating the tiles, right? So I had that final output on base of an ML meaning. So feature engineering depends on you create a variables to have the meaningful to the existing transaction records. So on top of this particular goal predicted tables, I created few tables which will act as an meaningful for my dashboards. So these are the some Spark SQL syntax and data frame and which I have created for my creating the tiles which I mentioned on the dashboards. So each everything which has an additional calculation tied up into it. So I think these are the like top risky accounts, and all such components are used for the typically for dashboards. So I would say so that's pretty much things going on. So on this particular thing, and later on, right? So I have created a view also. So I had because each what we're doing is that we are as part of tile building for that particular dashboard, right? I've been creating each and every uh, table, small tables to integrate small table to show in the dashboard. At the end of the while designing the dashboard, right, I need to have a single key element for my dashboard so that business can take a decision. So that single variable is nothing but transaction type. So and based upon the transaction type and all that other key columns, I created a views. That's what it shows. So this is a particular view where my dashboard is built. So that's a good practice. You have a view created for your reports so that it'll. So I think these are some things standard practice which I've used that is a pipeline. Yeah. So these are null value checks. So basically, it's best practice to have your once you created your uh, uh, pipeline gold layer prediction pipeline. It's better to have those. So such validation to it. So I just did some three validation, and if it any of those flags are passing up, then it will be showing in that particular dashboard. So that's what here kindly that feature is it shows 0 because this data is pretty clean. So there is nothing much we could show as an alert over here. So these are like um, jobs and dashboards, everything which I explained over here. And I think that's end. We are coming to end. Before I step to the closing up, let me open the yeah. I initially told I had two documents. So one is like what is data set, some columns to it, and what are the three models. Since it's a classification prop and classification models, what are uh, uh, three models which have been used, and other one is what are the evaluation metrics, everything. So and I should be initially I thought these are the key elements which is part of this challenge. So I just listed out. So this is something uh, based upon these key elements only which I choose in this particular data set. So this is something which talks about more about data set and what model I'm going to be choose later on analyzing that particular problem. And we have one more thing, yeah, documentation ending up. So documentation, I think pretty much straightforward, and I have ensured I removed those jargons, kept so those simple to the ML terminologies, few related to data qualities, and few related to feature engineering have been used, and few related to what is the key element of this problem, and what all the how I am going to drill down this particular problem into in the ML pipeline and registering the model. So those documents is what I would try to bring it out in this particular thing, and how the business is going to get impact as this dashboard will act as an precaution measures for anyone who is who is using that mobile transaction and jumping into those things. It will act as an precaution KPI, key-based indicator for the people who are making the decision out of it. So these are that overall insight of that problem, and I created dashboard. I created slides for it. So this is all pretty much what I told. What is the business context? So it's basically used for to mitigate the financial losses which you had done, and my objective is nothing but it's mobile payment and how to do the some history of transaction. Like we have like 6.3 million records. How we are going to do those checks and precautions. So the objective is nothing but you build that data pipeline and fraudulent and data pipeline and ML pipeline to analyze and streamline it and provide that recommendations to the end users, that is the business. So this is one of the chart which I explained it in the beginning of the session. So yeah, feature engineering, which I just mentioned what all the key elements, what all the key features of it. So if you check on that, most of that feature engineering problems I just built on top of that AUS which has been identified, and based upon that only I've just classified how it really distinguish between the legitimate and the fraudulent transactions. Fraudulent, I make sure how it the prediction if it is saying one, then we call it as legitimate. So those things is what I mentioned over here. Yeah, Delta Lake. So it's pretty much important. So all things, either gold, all the Medallion architecture will build on Delta Lakes. You will have the logs, everything captured. So basically, it's used for content asset properties. You can do the time travel when you do for this Delta Lakes. And other one is its performance wise also get increased. But this is a short data set. When you go for a lot of things, this really thing really. So time travel, all such things. That's why each and every symbol tile also I've just ensured it is loading into the particular uh, uh, delta frame within delta lake only. So yeah, so these are like components which I've used on this. These are business insights. So these are pretty much try to explain mimic. I've just explained verbally what is objective, what all the section logging, everything, what is performance, everything I've explained it. So that's all about my project submission. So once again, the problem was identified, and we have provided recommendation with help of binary classification. So this simple classification problem I'm able to explain you with and able to try to bring more insights with help of a dashboard. Use the Medallion architecture, which has a proper standard of using proper registration, ML pipeline, proper modeling, feature engineering, everything end to end has been uh, done for this particular project. And I hope I gave him explanation what all possible way with this 10 minutes of video. And once again, I give my thanks to all the members of Indian Data Club, Codebasics for creating this structured thing, and also for Databricks for the sponsoring. Thank you. Thanks so much.